Right, so we're looking at question 9 now. The curve y equals bracket x minus 1 all squared maps onto C1, stretch scale factor of a half in the x direction. So it's in the x direction, so we're looking inside, so we've got to look inside here. That one shifts it. The coefficient of x is the stretch. If it's scale factor of a half, then that will be 2 inside there. So you literally get it like this. And then of course it says, show that this can be written as 4x squared minus 4x plus 1. So let's expand this out and you can see that it's 4x squared minus 2x times minus 1 is minus 2x, minus 2x minus 4x plus 1. And that's what they wanted. Then it says the curve C2 is a translation of my life. It's a translation of y equals 4.25 x minus x squared by translation of 0 minus 3. Okay. So this is my C1. Let's remind myself. That's my C subscript 1. And the normal of that. Now normal is to do a gradient, so I want to differentiate this. That gives me the tangent at 1, and then it's a negative reciprocal to find the normal. So let's differentiate this, and I get 8x minus 4. I know that at coordinate point 0, 1. So if I put 0 into here, I know that I get my gradient of the tangent is minus 4. So of the normal, it's going to be a quarter. It's going to be a quarter. So remember that. So gradient of normal, and it's good to write all this out, is going to be a quarter. And then I'd like to know the equation of this, because that's important. So y equals mx plus c. And here this tells me at the corner point 0, 1. So I put that in there. I can see c must be 1 there. So now let's look at the question. I might have to wipe this off. It says show that the normal, so this is a normal, at the point is a tangent to this one here. And I've got to show that this normal at the point 0, 1 is tangent to the translated curve here. So I've got to show, if I can show that this, first of all, that they collide, that there's an intersection. If there isn't an intersection, there can't be a tangent. And if I can show they intersect, work that out, then they must have just one root for it to be a tangent. If there's 2 roots, so it's got to be a repeated root. If there are 2, then it crosses through, but it's not at a tangent. So first of all, there's this translation 0 minus 3, so it literally drops it by minus 3, and that equals a quarter x plus 1. So now what I do is I form a quadratic here and then solve it, and hopefully I guess get a repeated root, and that will show that it's a tangent. So I've got the minus here. I'm going to shove everything over there because that makes it a lot easier to contend with. So I end up with 0 equals x squared. Okay, and then when that goes over there, nicely, thank goodness, there's a quarter here. So it becomes minus 4x. Add there, so that is plus 4. So, you know when it gets tidy like that, you're likely to be okay. So now let's just see if I get repeated roots. So let's just see. That's a minus, that's a plus, so 2, there you go. So it's got repeated roots, so when x equals 2, so yes, and because of that, because it's a repeated root, then it's a tangent at it. Quite a complex question, but we are talking about question 9 here, so it's a case of going through it nice and slowly. Look what I've done, and you should be fine.